Welcome to the Industry 4.0 Club's Fireside Chat. The club's purpose is to engage the power of diverse worldwide talent to accelerate the global evolution to Industry 4.0. We accomplish this by hosting and supporting respectful, thoughtful, and interdisciplinary open conversations and creating quality content on wide-ranging Industry 4.0 topics to expand the reach of our community. My name is Mike Ungar, and I am the CEO of the Industry 4.0 Club. I have over 40 years of leadership and experience, with most of that being in manufacturing at Michelin. Today, we have the pleasure of speaking with John McEleney. John is the co-founder of Onshape by PTC. John will be giving a presentation at MD&M East in New York on May 21st, 2025. The title of his presentation is Automating Additive Manufacturing, Shaping the Next Generation of Product Design. So just a quick introduction about John, more about John. John's a seasoned industry leader with over 3 decades in mechanical design and software. His extensive experience equips him to address innovation challenges in the hyper-connected digital era. He serves as corporate strategy advisor at PTC and is the founder of Onshape, a cloud-architected SaaS product development platform that enables on-demand design and real-time collaboration among engineers. John also serves as a director of Stratasys, a leader in 3D printing. His academic credentials include a BS in mechanical engineering from the University of Rochester and a master's in manufacturing system engineering from Boston University, as well as an MBA from Northeastern. So, John, welcome. We're glad that you could take time to join us.
Thank you, Mike. Glad to be here.
A quick comment before we get into our discussion today. For those joining us live on LinkedIn, if you have a question for John during our discussion, please feel free to put that question in the comment box, and we'll do our best to get to it during our conversation. So, John, just to get us started, when did you first become interested in additive manufacturing?
Well, I was a mechanical engineer at the University of Rochester, and perhaps to understand additive manufacturing, let me just briefly give you kind of a look into my practical background, if you will. I've always been sort of interested in sort of designing and fixing and pulling things apart and seeing how things work. And early on, I in high school and in college, I did a lot of work in computers. But I had one summer internship, and that summer internship was between my junior and senior year. And it was working at this laboratory for laser energetics at the University of Rochester. And this is a 1 trillion watt laser. So imagine 3 football fields long.
Yeah.
And we were designing. I was designing. It was doing high energy physics research, basically for nuclear fusion. I wasn't doing that. I was helping to do some of the mechanical design. And at that time, we were doing design on drawing boards, mechanical drawing boards. And a couple of weeks after I started, my boss sort of gave me the backhanded compliment. He said, "Hey, you're better at computers than you are design, right?" And so that summer, he asked me to help him find a CAD system because PCs were just starting, and we had thousands of drawings all over the place, and we needed to kind of get things organized. So I found a CAD system, got the mechanical cabinets, if you will, to hold the drawings, and then took DBase and wrote an application on top of that to do a drawing retrieval system. So very early on, the sort of CAD and design side of things really got me excited and interested. And I spent most of my career in that world, as you had read earlier. But from that information, and when I started working for an early CAD pioneer, computer vision, I got introduced to 3D systems and kind of the first SLA sort of systems that were out there, and started spending some time with that and was very, very excited about it. And then as I moved to SolidWorks, and I was the CEO at SolidWorks for many years, I met, of course, many of the sort of startups at that time. One of them was in our backyard, was a company called Z-Core, and started spending more and more time about understanding how you can take a digital 3D model and really kind of get a prototype in your and a functional prototype in your hand a relatively short time afterwards. And then I've been involved at Stratasys on the board. And, Boston's kind of a hotbed for additive manufacturing. So
Yes.
All the players involved from Markforged to Formlabs to Desktop Metal, and most of those people I've been kind of involved early on, understanding and spending time with them. So it's been most of my career sort of formulated by the design side or informed by the design side. And then as 3D printing and additive sort of evolved, I kind of immediately kind of grabbed a hold of it and got very excited about it.
Well, that's neat. That's an interesting journey. It's fun to think about how we evolved to where we are today. I always like to tell the story. When I started in manufacturing, we had one computer in the plant. We ran the equipment with Silamog, and so you think about these evolutions like the one you just described. Uh, it's amazing to think about where we started isn't where we've ended, in
For
terms of
sure.
where
Thank
things
God.
are today. Well,
Thank
no, it's
God.
amazing, and it's still moving at a pace that's unbelievable, huh?
Yeah, changes every day, and yeah, and additive, additive. We'll talk about it a little bit later on, but it's gone through its own sort of challenges over the past couple of years. But with that, there are green shoots of new opportunities, which typically happens in an industry as it evolves.
Well, that leads me to really ask you about more about additive. I've tended to think about additive in terms of prototyping or very small production runs. Um, but that's evolving. So are there certain sweet spots today for additive manufacturing that you would say, hey, this is where mainstream is, and maybe talk a second about, what the future holds?
Sure. I mean, if you think about additive and you think about CAD in general, which is it's really kind of like Microsoft Word or PowerPoint is the CAD side of it. And then your laser printer was effectively your printer. So if we use that same sort of metaphor and you think about the CAD side of it being the sort of the document creator, if you will, CAD has done a great job of really evolving the digital simulation, if you will, of what a part would look like and what a part ultimately can be tested and verified. So we as an industry have moved from lines and arc, which is trying to articulate what the end design would be, to now allowing you to iterate, which is in fact, engineering is all about iteration, right? As you learn more
Right.
data about how your product is performing, you want to modify and iterate your design. So on the digital side, on the front end, the simulation of design, iterating on the design, getting data and feedback of really functional performance digitally allows us to iterate and create a design. But then you want to actually sort of get a part in your hand. And so prototyping really has been a very powerful tool to help influence that feedback loop to the design side of the cycle.
Yes.
And as technology has improved and as materials have improved and the deposition of those materials has improved, we've not only gotten prototypes that we can actually physically see and that are dimensionally accurate, we can actually get functional prototypes. So we can get prototypes that can deal with higher temperatures and some of the characteristics of how a part may want to be tested. So prototyping has been an incredibly important part of influencing how a design will perform and therefore allowing further iterations and hoping getting to get the arrow right for what for the target of what we want in terms of the end design. That being said, the industry in additive, it really is going through its own evolution, which is to come from this part visualization and realization through to actually building and manufacturing sort of end use parts. And I think there's kind of a couple of themes that are really interesting in terms of sweet spots. One is we've always had in the design and production world this idea of mass customization. How do we get something that is specific for each customer, but also get the benefits of mass production? Famously Henry Ford, you can get any car color you want as long as it's black.
Yes.
The idea of being able to take a product and be able to very specifically customize it for a customer and be able to still get the economies of scale of large scale production is really kind of the holy grail. And in the additive world, some of these technologies truly do allow new businesses to be born. And the greatest example of that in the additive world and in the design world is actually the Invisalign story, which is these digital retainers, if you will.
I never thought about that. Yeah, I never thought about that.
So if you think about what happens with an orthodontist, old school, the drafting board equivalent analog to the orthodontist was them sitting there putting the pieces of wire and twisting them and the rubber bands for kids getting the braces right. Well, now a lot of orthodontists will sit there and they'll take a scanner and they'll create a digital scan of your model as is, meaning your teeth as they are. And then working with the Invisalign and aligner companies, they'll take that digital model and then they'll actually simulate a treatment plan that might be over 18 different trays, if you will, which might represent a total of 36 weeks or even could be a year. And digitally, they'll kind of move the teeth a little bit each time. And then using additive, they actually can go and produce those trays in an automated fashion so that you can get 18 sets of these retainers that then they vacuum form it with material that you can actually put in your mouth. And that can actually over time move your teeth and actually replace the bands and the electrical wires or the wires.
Well, I wish I had that when I was 13.
Well, it's if you see the amount of people that have been able to get orthodontic treatment, it's done two things. One, it's made it easier for people to get the treatment and allow more orthodontists to actually and dentists to be able to apply this technology, but it's also made it more affordable.
Yeah,
and so if you look at dental health, which ultimately leads to better health because you solve periodontal disease, et cetera, that it's really been beneficial. So that's a sweet spot it's a sweet spot for the industry. It's a sweet spot for customers, and it's a sweet spot for the vendors that produce a lot of the materials that get production because it's a very profitable business.
So what you're saying, if I can conclude then, is that's an example of where we went from prototyping and we can take small runs where that customization is key and make it available to the masses.
For sure. And if you look at the Invisalign production system, it is highly automated to the tune that each one of those little trays that they make, they index it with a QR code to know exactly which tray it is, meaning week number 1, week number 5, week number 10. And that's completely automated. It's hands off for people being able to, produce these things. So yeah, it's large scale manufacturing. So the mass production capabilities, but customized for every single individual person. I'm not wearing the, Invisalign that you'd be wearing. It's customized specifically to you. That's one.
Yeah.
So we're seeing in the additive, sweet spot, in the additive space, dental is an area that is quite interesting, actually. And it's a large business. Gone further is that the denture market, actually, in the dental industry is today, a bunch of lab technicians that are handcrafted, very art sort of oriented, specific people to put dentures together. Right. Now, using that same kind of analog, if you will, of what has been happening for these for the digital braces, if you will, the aligner market, that's now happening for dentures, actually, where people can get production dentures. So dental market's really great. Then if you look at the high end, the sweet spot is we've seen in metal manufacturing. And metal manufacturing has had its successes and its failures, no question, like most markets. But I think the classic example of where new technologies create a huge opportunity is the GE jet engine nozzle. This is a nozzle to inject fuel into the turbines. That fuel injector in the past was 20 pieces of titanium that were brazed and welded together. That was very complex. That required jigs and fixtures. And now that actually they targeted a very high value application that with cobalt chromium they've been actually able to 3D print a metal part that replaces 20 parts for that nozzle. What's interesting and unique about that is think about the economic value of being able to do that. And what I mean by that is forget for a second the manufacturing, the welding, the brazing versus a single printed part. Think about just the documentation, the logistics, and the tracking of all of 20 different components going into one jet engine. Traceability and the cost associated with that is dramatic by getting it down to one part. So that's so high value added application that arguably is much more niche, but we're starting to see areas like that where it's high return, highly specific. That part reduction and the unique characteristics of additive as compared to subtractive processes are creating value for customers.
That's amazing. And I'm going to take what you said one step further. I'm not sure they're ready to do this yet, but one could imagine a 3D printer at the Atlanta airport, where when they need a part, rather than have them all in stock, right? All they do is they print what they need. It sounds kind of crazy, but when that's already been developed, you can imagine where this might go.
Yeah, there are field-related printing activities that are happening in the Department of Defense and other related sort of places. And there are, Stratasys had a project with Singapore Airlines for non-mission critical parts, if you
Yes.
will, that they didn't necessarily have to store all the individual parts in inventory to be able to do trays and different fascia panels and stuff like that. So there is work underway to go and do that. And it's as somebody once famously said, horses for courses, meaning that you don't go take a thoroughbred and put him out as a workhorse pulling a hoe out in the field, but you don't take also a Clydesdale and put that in the Kentucky Derby. So there are specific things that you can take for the techniques and manufacturing processes for additive that can be value add for on-demand type parts.
You kind of looking back to the title of your presentation is Automating Additive Manufacturing, Shaping the Next Generation of Product Design. Can you talk a bit more about what does it mean to automate additive manufacturing?
It's a really great question. When we talked about some of these things we were just covering, when you think about automation, it's what are the things that you can do that the computer can do better, and that we can speed up a process. Because you got to think about the design and the manufacturing process. Even if it's something that once you hit the button and starts going and does it by itself, there's plenty of things that need to be done in advance to make that a defined process. For example, if you're going to print many parts, one of the things you want to do is not just print one at a time. You want to nest them inside of the volume of the material, how it's going to be manufactured. So nesting is something that we can automate and logically lay out how things are going to be built. We can look at when we're doing that nesting to make sure we've got the part as it's being manufactured, that it's oriented in the right direction, so you're getting the maximum sort of Z strength or tensile strength to be able to hold things together. We're looking at how do we take manufactured parts, if you will, or small lot manufactured end use parts, and how do we think about these machines as a series of machines working together in parallel? So how do we do load leveling of what parts get built where inside of call it an additive manufacturing sort of facility, if you will. We can think about all the monitoring required to make sure that we don't run out of raw material. How do we automate the loading and unloading all the parts that come in there? As we're looking and iterating in the front end of the process, how do we go and iterate on the design side and say, okay, that's iteration 1 that's going to print on that machine. Iteration 2 is going to print on that machine. So we can take things and try and parallelize them, so we can then do real-time testing to be able to shrink and parallelize activities together. And then
makes sense.
That's just on the design part of it. When you think about also as these things get printed, not everything can automatically be printed without thinking about support structures. And the classic example is a margarita glass. If you're going to print a margarita glass, it's going to hold that beautiful margarita at the end of the week that you want to have. Well, you got to make sure it doesn't collapse because of gravity. And so you have to have support structures in additive manufacturing. Very well-known process. And depending on the material, some of these things can be automated, can be dissolved through water. Some of them are water soluble. Other ones need to have you snap off the support structures, or some of them have powder and you have to remove some of the structures. So this whole idea of post-processing, how do you take that part that's been then printed, if you will, there's a post-processing, and how do you make sure that you automate that? In metal parts, you do it typically through a binder of kind of powdered metal, but then it has to be sintered. So, when we look at that automation of sintering it, depending upon the aspect ratio of the part, if it's a thin part but big and long, think a piece of paper. If it's thin like that, then you're going to have thermal characteristics that might make it look like a potato chip. So you got to plan for those stresses. So depending upon the part, there's many things you can do to pre-stress it or change and deform it so that when it does stresses, it comes back to the nominal shape. So there's a fair amount of things that need to be done to automate it. And so these are some of the tools that are available both on the design side from companies like Onshape, but also on the manufacturing side from the vendors that are producing these machines and building the software to help do the manufacturing.
That's really neat. Now, I was reflecting as you were talking about, I spent most of my career in the tire industry and at Michelin. And I remember where we were able to take additive manufacturing and apply it to mold manufacturing, tire mold manufacturing, and actually, because of the precision that you get with an additive, create better performance, better molds, and therefore better tires with better performance than we had previously due to the technology evolution. And and for a company like Michelin, whose reputation is longer wear, better gas mileage, those things are huge. And so a really big deal for us.
Well, and it's also, it can impact, Mike, it can impact the economics associated with product design and parts. And let me just explain, building off of what you just talked about in terms of what you did at Michelin, is that if you think about any kind of mold that you typically will have to do an injection molded part, think of Microsoft mouse, if you will, you can build a mold that would be very, cutting the metal and making the mold is very expensive. But if you're amortizing the cost of that over, 10,000, 100,000 or millions of parts, then of course, the idea of injection plastic molding is extremely refined process to get the cost down and the quality up, which that's the marvels of modern manufacturing. The challenge, of course, is that not everybody is building millions or tens of thousands of different parts.
Yeah.
So the question is, can additive play a role? And this is where I think over the next couple of years, this is going to be one of the most transformative things in terms of manufacturing, which is, I think, the idea of printing mold inserts, because you can use high temperature plastics to go and actually, instead of machining the mold, you can take standard molds, put an insert in that's been 3D printed with high temperature plastic material, and be able to take the economies of scale that would only be accomplished with hundreds of thousands of units and be able to do it for 4,000 units. And that's going to change how and what people do in terms of manufacturing. Yeah, that's one of the ones that hasn't necessarily reached the mainstream yet, but to me, that's one of the most exciting parts for manufacturing.
Yeah, that's cool. That makes a lot of sense. Any other future applications on the horizon that you might want to share with the audience today?
Yeah, well, so I think it's a very exciting time in the additive world. Even though if you looked at the public companies and you looked at a lot of the startups that kind of flamed out or got acquired, it's kind of been honestly a very challenging year, past 24 to 36 months in this business.
Yeah.
That doesn't mean that there's not value and long-term value. I believe there is. It's just been a consequence, in my opinion, of oversupply of capital, meaning there was a lot of venture capital dollars and people that were sort of basically taking the concept of what additive could do and bringing it to really crazy thoughts of what was possible. And it created sort of a dynamic of competition and flooding of the market with not necessarily completely baked solutions. So what we've seen now is there's been sort of an element of destruction in the market, but we're starting to see green shoots of opportunities happening in the market. Much like we had the .com crash, I would say we'd have the 3D printing additive crash, if you will. And we're starting to see sort of some of the leaders survive and move forward now. What I'm excited about is this. Along the way, there's been a lot of work done on materials development. I think, that is something that over the next 5 years, you're going to see some amazing new materials develop, both performance in terms of structural performance, but also temperature performance and longevity. So I think that I think is really exciting. So you're going to see a lot of work done on the metal side. I think you're seeing a lot of innovative work being done on the software side and motor controls to actually help improve build speed. Specifically, as a head, for example, in an FDM type machine, fused deposition modeling. For people that don't understand, this is sort of like, imagine the spaghetti of plastic, if you will, being exerted out and it's on an XYZ sort of plotter. The ability for software now to be able to allow that to move faster and predict where the end part's going to sort of have to stop and slow it down. And so it allows it to go 80 miles an hour and then slow it down right before the end and not have kind of vibrations. So software and controls are playing a bigger role and will continue to play a bigger role in design to improve the speed at which things can be basically taken from design through into production. And also software has done a great job. I mentioned before about warpage and predicting and pre-stressing things. I think we're making a lot of headway in terms of pre-processing so that the post-process, we get the end product that we like. And then in the high-end markets, I think we're going to see really kind of solid growth where people are seeing, there's new manufacturing techniques to do things, for example, drones and crazy things that might happen in the defense sector that heretofore were a typical sort of manufacturing sort of world.
Well, that's really good. So as we begin to kind of wrap up this afternoon, we've been talking with John McEleney, who's the co-founder of Onshape, about, I guess everything additive, which is great. I really appreciate that. So what do you hope people who attend your talk in New York on the 21st, what do you hope they take away from your presentation?
Yeah, so I think, having been in this industry for a long time, specifically on the design side of things and looking how it impacts other sort of steps in the process chain, there's a sort of a traditional process. And, look, I was a very early person at SolidWorks and sort of traditional, desktop installed software. It helped tremendously, propagate 3D and propagated throughout the whole manufacturing world. But it also created some problems. And so what I hope that people see when they come to my presentation is to learn about what a cloud-based native sort of SaaS application, when we started from scratch and kind of pushed the old systems off the table and started afresh, that we've actually solved some of those core problems that created of the simple issue. I'll point it out to you, and every person who's listening or watching has had this problem. If you've ever worked on a PowerPoint with somebody and you have to give a presentation on Monday morning, and you sort of say, well, can you add this slide? Somebody has the master sort of presentation. Somebody says, well, put this in as slide 17. And then you come up with a naming schema that says, final version as of Sunday at 7:59. And then, then you change the name again to really, really final version. And so this whole versioning issue kind of goes out the window. And as a result, all the processes downstream become streamlined, and it allows you to iterate. And taking from the software world, we've created this idea of being able to branch and merge and explore various versions of things. And that whole iterative nature that we talked about from prototyping on the manufacturing side, that's happening in the software side that allows you to explore on a broader basis. And the two of them together really can optimize how people build things.
Wow. Man, it sounds like, not to be cliche, but the sky's the limit on this,
Should be very exciting.
Yeah. So as we get ready to wrap up, any final thoughts for our audience today?
As usual, when you have major sort of challenges like this market has had for the 3 years, everybody will probably look at it and poo-poo and say, 3D printing's dead. It's not dead. Just like the internet was not dead after 2001, I assure you. And so it's actually a very exciting time, because now you're going to start to see rationalization and usage of great materials, new products, help transform things. And we want to be the partner of choice in the front end of the design solutions to help people. So I'm very optimistic about design, manufacturing, making better products for all of us that we consume and use every day.
Thanks, John. I appreciate that. Well, this has been a great conversation. I want to thank you for joining us and giving us a preview of the presentation you're going to be making at MD&M East on May 21st at the Javits Center in New York City. We hope that you're going to join us. That's only next week. I can't believe we're already here. If you haven't yet registered for the event, please go to the website, mdmeast.com. There you can register for the exhibit and join, John on the advanced manufacturing stage on the 21st. So please join us and join the Industry 4.0 Club. We'll be there as well. The Industry 4.0 Club would like to encourage you to take action to advance the deployment of Industry 4.0. Read an article, attend a workshop, or develop a smart manufacturing roadmap for your plant or your company, or challenge them to move forward with the deployment of Industry 4.0. We'd like to know what you're going to do, what you're thinking about. Drop us a note on our LinkedIn page or at our website at www.industry40club.com. We also would love to have you on one of our broadcasts. If you'd like to join us there, again, drop us a note at our LinkedIn page or our website, and we'll reach out and see if we can't find a way to get you on a broadcast. So on behalf of the club, John, and MD&M East, thanks for joining us. And I want to wish everybody a wonderful rest of the day and week.
Thanks, Mike.
Take care.